Hi and welcome to the Mathemagic channel. Today we look at why anything to the power 0 is equal to 1. Let's go. So a few things to think about here, and what we're going to look at today is what it actually means in practice, how do you use it, how we got there, and why it's absolutely essential that anything to the power 0 would be equal to 1. So let's first start with how we use this idea. In practice, anything to the power 0 is 1. What does that mean? Well, if you have 3, which is a number, to the power 0, the result is 1. If you have 10 to the power 0, the result is still 1. If you have 1,000 or billions of billions of billions to the power 0, you still get a 1. Now, if you have a variable x, now a variable, remember a variable can represent any number. Well, necessarily, because it can represent any number, and any number to the power 0 is 1, x to the power 0 will also be 1. And similarly, even a negative number, so like negative 3 to the power 0 will also be 1. Now, where this can confuse some children is where you have negative 3 to the power 0. Now, notice the negative is outside, there's no bracket, and then 3 to the power 0 might happen first. Because of the order of operations, which is BEDMAS, exponents will happen before addition and subtraction, and minus is kind of like a subtraction. So 3 to the power 0 happens first, which is 1, and then takes a negative and becomes negative 1. So this one can be a little bit tricky, but make sure you realize that the power 0 is just given to the 3 here. And similarly, 5a to the power 0, the power 0 is given to the a here. So a to the power 0 will become a 1, but then gets multiplied by 5 afterwards. So make sure that you respect exponent rules. Exponents go first, they go before multiplication and division, and so that can be a little bit important from time to time, and in those cases it is. If, however, you have 5a inside of a bracket, so all of that to the power 0, then whatever is inside the bracket becomes a 1. Okay, so in practice, this is how you use it. Now, how did we get to that result? Well, a lot of students often get confused by that statement. So why is it true, and how can we make sense of it? A good thing to think about is to look at exponent rules and how powers are represented. So maybe we can start with representations of powers first. And if we think about it, 2 to the power 3 is 2 times 2 times 2. 2 to the power 2 is 2 times 2. It represents the number of 2's that we have. 2 to the power 1 is a single 2. And so you could write 2 to the power 3 as 1 times 2 times 2 times 2. You could say that 2 squared is 1 times 2 times 2. You could say that 2 to the 1 is 1 times 2, and therefore 2 to the 0 has no more 2's left, but is still a 1. Now, if you're not happy with this argument, that's totally fine. We can get there in some other ways. You can think about how exponents are connected to each other. So think about this. 2 to the power 3 is 2 times 2 times 2, which is 8. Now, if you divide that by 2, you get 2 to the power 2. So dividing by 2 is the process of removing one of the powers. So you'll get 2 squared, which is 2 times 2, which is 4. Now, if you divide that by 2 again, you'll get 2 to the power 1, which is 2. And naturally, if you divide that by 2, you'll get 2 to the power 0, which has to be 2 divided by 2, which is 1. And so this kind of works when you think about how exponents are connected to each other. So why is it essential? Well, it's a good connector in terms of your power laws. Your algebra has laws and stuff has to work with the rules, or at least it has to make sense. And it's the idea of what we call the identity element. So how does it connect your power rules? Well, here it is. If you look at the addition rule, for example, 2 cubed times 2 squared is, so the green ones are 2 times 2 times 2, representing 2 cubed, and the purple ones is 2 times 2, which is 2 squared. And so you notice that all together you have 5 2's, and this is what we call the addition rule. So it becomes 2 to the power 3 plus 2, which is 2 to the power 5. So when you're multiplying numbers, you can add the exponents. As long as the base is the same, you're allowed to add the exponents. So if we look at how this works with multiplication here, so 2 to the power 3 times 2 to the power 0, we notice that 2 to the power 0 gets added to the 3, and so 3 plus 0 will still stay 3, and so we have 2 to the power 3. And so we've left 2 to the power 3 unchanged here. We had 2 to the power 3, we multiplied it by 2 to the power 0, and we still have 2 to the power 3. which number do we know, which is the only number that allows you to leave a number the same under multiplication rules? Well, it's 1. 2 to the power 3 times 1 will be 2 to the power 3. So the only way that this works is if 2 to the power 0 was actually a 1. So that's a very good explanation for why it works under addition laws and why we need it to leave a number unchanged specifically. So in other words, it's necessary for it to be a 1 so that 2 to the power 3 remains the same. And something similar happens to your subtraction rule. So when you have 2 to the power 3 divided by 2 squared, usually for the same reasons as before, we subtract the powers. So we're going to do 3 minus 2, which is 2 to the 1. So we get a single 2 here. Now, if you have 2 to the power 3 divided by 2 to the power 3, you end up with 2 to the power 0 because it'll be 2 to the power 3 minus 3. So they get subtracted. Now the thing is, 2 to the power 3 is actually a number. It's 8. And so if we said 8 divided by 8, you would know that you get 1. So let's remember that for any number, when you divide it by itself, you get a 1. So 2 to the power 3 is a number, and you're dividing it by itself, which is also 2 to the power 3. So really, this is the process of doing 8 divided by 8, which is 1. And so 2 to the power 0 must be the same result as 8 divided by 8, which is 1, for the subtraction law to work. So what does the phrase identity element mean? Well, identity elements leave things unchanged under certain operators. And to be more specific, if you multiply a number by 1, well, 3 times 1 is equal to 3. We leave the element unchanged, so 1 is an identity element under multiplication. So this is part of what we call group theory. And so if you multiply something by 1, it doesn't change. Under addition, if you add 0 to something, it doesn't change. So under addition and subtraction, the identity element is going to be 0. So 3 plus 0 is still 3. And the same happens to your exponent laws, where 2 to the power 0 will become the identity element for your exponent laws. So when you're using your addition law, the 2 to the power 0 section is going to be your identity element. So we hope this clarified the idea that anything to the power 0 is equal to 1. As always, please remember to like and subscribe to the Mathemagic channel so we can keep bringing you more mathematical content. Wishing you all the best at school and in your studies in mathematics. Please remember to like and subscribe, and see you on the next video. Bye-bye.